Hello to all my bacha party. Namaskar, adab, sat sri akal, and game show. Welcome to the class of DSP, the finance and the to learn the concept in this channel. Here you're going to feel the physics, and then you realize that you are in fall in love with the subject. And today's topic is about the dimensions. Last video lecture we will talk about the units. At first we will recall them. Last video lecture we will talk about what is the physical quantity, and there are three kind of physical quantities. One is our fundamental quantities, another is our derived quantities, another is our supplementary quantities, and we will talk about them. And today we will talk about the dimensions. So what is a dimension? If I will say is that dimensions are the powers to which the fundamental units are rises in the order expressed to the derived units of a quantity. Means the dimensions are the powers of a physical quantities. Suppose there are 7 physical quantities that will be know in our previous lecture, and here there is a length, another is the mass, the third one is the time, fourth is the temperature, fifth one is electric current, and sixth one is our amount of substance. The seventh one is our luminous intensity. So length, mass, time, temperature, electric current, amount of substance, and the luminous intensity. There are 7 physical quantities, fundamental physical quantity. So how you can find the dimension of this? So for length you can use this as the dimension of a length. What is the difference between dimension and the units? Suppose the length has a lots of units in SI, meter, centimeter, kilometer, decameter, decimeter, inches, foots, and hands. So there are lots of units, but there are no standard unit. Only standard unit is SI. But here we will use the symbol of a length. So this symbol of the length is L, and the symbol of mass is M. Time is T, and temperature, because of time is T, that we will not use the temperature T. Here we will use the SI unit of temperature is Kelvin K, or some people will be used as a theta. This is given in the question. Which one is given? Then you can use this. And the electric current is ampere. Means A. Amount of substance is mole. Luminous intensity is candela. So luminous intensity is a candela. So these are the dimension of a length, mass, time, temperature, electric current, amount of substance, and luminous intensity. Now we will make the dimension of a fundamental. We can find the dimensions of the derived physical quantities, such as we can use the area. Area is the unit of area is meter square, and the dimension of area is length square. Means length square means length into length. So what is the square? Means what is the dimension in the area? The dimension of the area is length to the power 2. Dimension are the powers. Dimension are the powers. Means this one is the dimensions. So these 3 dimensions means length, mass, and time will be very most or very useful. Other 4 quantities, we will not use this in this video. We will use this in the next video. So area m0 L square T0. So that is the dimension of our area. according to the basis of length, mass and time. The second one is our volume. The volume is meter cube. What is the meter? Length cube. So we can use this as m0 L cube T0. So what is the dimensions? 0, 3, 0. These are the dimensions according to the mass, L and T. Mass, length and time. Now all we find about a common physical quantity named as displacement. What is the displacement? dx by dt. Okay? What is the dx? Dx is representing the length and this is the time, so you can write as L by T. So you can write m0 L1 to the power minus 1. This is the dimension of our displacement. Now we'll be talk about the velocities, angular velocity and other terms. Now we'll be find the dimension of velocity. What is the velocity? Displacement by time means dv by dt. dv by dt. Displacement by time. Sorry, dx by dt. That is the velocity. So we will use what is the dx? Length and time means t. So the velocity is, you can find m0 L1 to the power minus 1. Now we will find the density. What is the density? Density is, the unit of density is kg meter cube. So you can write as kg per meter cube. Meter representing length means L cube and kg is the mass. So you can write as m by L cube. So you can write as m1 into the power minus 3 and t to the power 0. So this is the dimension of a density and the velocity. Now we find the dimension of a force, acceleration. Now what is the force? According to Newton's second law of motion, force is equals to mass into acceleration. Okay? So force is equals to m into acceleration. We can find acceleration as a dv by dt. Here the dv is the velocity. So you can write as dx by dt m into, what is the dx? Is the length by time by t. So we can find the force is m L to the power minus 2 means m1 L1 to the power minus 2. And here we can find the acceleration. The unit of acceleration is meter per second square, so we can use meter as a length by time square. We can write as m0 L1 to the power minus 2. So this is the acceleration. Now we will find about the speed. Speed and velocities units are same. If there are units will be same, so the dimensions will be same. So now let's move on to the momentum. Momentum P is equals to mv, mass into acceleration. Sorry, mass into velocity. So you can write as P is equals to m is the mass. And what is the velocity? velocity is the length by time, L by t, so you can write as m1 L1 to the power minus 1. So this is the dimension of a momentum. Now we can find the dimension of a work. Work is a force into displacement cos theta. Means W is equals to F d cos theta. So we can find easily the cos theta has a numerical value. So there has a no dimension of a cos theta. Yeah, any real number. Okay. So the force, dimension of force, ml t to the power minus 2 into what is the displacement? The displacement we can find as L. So we can write as m L into L square into t to the power minus 2. So dimensions are m1 L2 L to the power 2 and t to the power minus 2. That is the force. So that is the work. Now we can find power. What is the power? Work done by time. What is the work done? M L to the power 2 and t to the power minus 2 into T. And you can find the dimension of power is ml t square and t to the power minus 3. So m1 minus 3. Now we will find about the impulse. So now we will talk about the impulse. What is the impulse? Impulse formula is F into delta t, means change in time. So what is the dimension of a force? Okay, m L t to the power minus 2 into the dimension of delta t is a t. So we can find m L t to the power minus 3. Is it clear to all? So we can find the dimension of impulse as ml to the power minus 1. Now we will move on to the angular velocity. So what is the angular velocity? What is the angular velocity? The formula of angular velocity is velocity by radius, means L into radius, means L into t because of velocity. So you can write as L will cancel and you can write 1 by t. So you can find t inverse. So you can write as to the power minus 1. So we can write as m0 L0 to the power minus 1. Okay, that is the angular velocity. Now you can find the dimension of frequency. Frequency is 1 by time. Means you can find t to the power minus 1, same m0 L0 to the power minus 1. So is it clear to all? Everybody, is it crystal clear? सबको ये बात चमकीला है? Now let's move on to the angular frequency. What is the formula of angular frequency? 2 pi into frequency. So the 2 is a real number and also pi has a numerical value, so there was no any kind of dimensions, and we can find the dimension of frequency is 1 by t. So we can find to the power minus 1. So we can write as m0 l0 t to the power minus 1. Is it clear to all? Now let's move on to the angular. Now let's move on to the angular acceleration. What is the angular acceleration? The angular velocity by time. What is the representing? We can change the change in angular velocity. What is the angular velocity? We can use and change in time. So we can write as this one as a t inverse. So we can write as angular acceleration is equal to m0 l0 and t to the power minus 2. So is it clear? Now let's move on to the moment of inertia. What is the formula of moment of inertia? I is equals to mr square. The I is equals to what? The I is equals to mr square. Mr square means I is equals to what is the m? M is the mass, so you can write as m into radius square means l square. So you can write as m1 l square t to the power 0. So this is our dimension of momentum of inertia. There are lots of dimensions. Okay, so there are angular momentum stress. So now we'll find the dimension of stress. So what is the formula of stress? Stress is equals to force per. We can know the force dimension is ml to the power minus 2 and area is the L square. So we can write as m L to the minus 1 to the power minus 2. Is it clear to all? Now we can find the dimension of strain. The change in length by the normal length means L by L means m0 l0 to the power 0. There are the quantities which has no dimension as well as no unit. So you can write as the strain is a dimensionless or unitless length quantity. Now we'll be find the dimension of a constants, such as the Coulomb constant, the universal law of gravitational constant, that is the G. So you can find F is equals to G m1 m2 by r square. So G is equals to F r square by m1 into m2. So you can find force m l to the power minus 2 into l square by what is the m1 into m2. So we can write as m l square to the power minus 2 by, so you can write as the gravitational constant has a dimensions. So the dimension is m inverse L cube and t to the power minus 2. ml to the power minus 2. Okay, is it clear to all? And this is our today's video. Till then, do whatever you want to do, man, but don't trouble your mind. Take care, bye bye, see you, stay motivated, and thank you for watching this video.